Well, welcome back from the break. I trust you had the opportunity to meet with Gary, network. I know I talked with 3 or 4 people in the short time that we had to break. Our next speaker is our manufacturing industry leading keynote. His name is Newell Franks. He's chairman of the board of directors and CEO of Burr Oak Tool and Oak Press Solutions. He was appointed chairman of the board of directors and CEO of Burr Oak Tool and Oak Press Solutions in 2006. He joined the Oak boards while serving as the assistant VP of operations for Burr Oak Tool in 2000. He has held positions of increasing responsibility with Burr Oak Tool since beginning his employment with the company at age 14. He's a mechanical engineer with a BSME from Brigham Young University and is also a member of the American Society of Mechanical Engineers and the Society of Manufacturing Engineers. Once again, you'll have time to ask a few questions after Newell's presentation. Please join me in welcoming Newell.
Thank you very much. You'll have to, I hope my voice makes it all the way through. A week ago, I spent a couple of days driving 5 grandchildren to Utah on my way to California, and they shared with me on the way there, and so I'm just now recovering from that. Those of you who have grandchildren understand. The Burr Oak Tool and Gauge Company is not unique in the United States, I don't think, and it's certainly not unique in the world. And the question I'm going to try to answer today for you is, how can U.S.-based manufacturing companies survive and thrive in the global stage? If you look around the United States right now, in my view, our manufacturing infrastructure is pretty well trashed. Modern Machine Shop magazine several years ago did a survey of U.S. manufacturers, and they were looking specifically at the machine tools that were in place on the manufacturing floors of U.S. manufacturers. And the statistic they came back with was that 80% of the machine tools that were in use were built by companies that are no longer in business. That is not a formula for success. It's my view that as a nation, we've been eating our seed corn for in excess of 50 years. And some of the challenges we have today are because of that. The Burr Oak Tool and Gauge Company, this is an aerial of the main plant in Sturgis, Michigan. We have, between our 2 facilities there in Sturgis, about 400 employees currently. And what we do is we supply the air conditioning and refrigeration industry around the world with machine tools they use to build evaporator and condenser coils. You don't recognize our name, but I think if you look at the names on the screen here, you recognize their names. Most of you probably have an air-conditioned home, and if you walk out in the backyard and you look in that air conditioner, or if you opened up your gas furnace and looked at the A coil inside there, there's an excellent chance that those coils were manufactured using equipment made right in our main plant here in Sturgis, Michigan. And we build a variety of machine tools that are used to do this kind of work. We make the dies that are used to stamp the fins. We make tube forming and tube fabricating machines that are used even in Tier 1 and Tier 2 automotive accounts. The machine in the lower left-hand corner is called a cutoff machine. And if you've ever been to the hardware store and bought a Delta faucet, those pre-cut, pre-bent tubes that come with that Delta faucet came off of a Burr Oak machine. About 2 million of those a year. I'm going to talk a little later in the presentation about 2 really innovative products we have where we use voice of the customer to not only go where the customer thought they wanted to be, but in a Stephen Jobsian sort of adventure to leap out beyond and get to a place where they didn't even know they wanted to go, but once they were there, they were thrilled. And I can't tell the story about our company without telling the story about how we got where we are. The guy up here in the upper left-hand corner is my grandfather, and he grew up in rural Indiana, and he graduated from high school and got married just in time for the advent of the Great Depression. Perfect timing, right? And he used to tell our employees a lot about what it was like to live then. And he said one of the things about the Depression that was interesting to his family was they had nothing. They were destitute. And he said, so when the banks failed, we didn't care because we didn't have any money in the banks. We didn't have any money to put in a bank. And the next picture there is a company photo from 1961 before we went international. And those 28 people constituted the entirety of the Burr Oak Tool and Gauge Company. Now, what's interesting about the photo is there's a lot of young guys in that picture, people who were in this picture in their 20s and 30s, who were great innovators. And they had a small group of people, right? And a brand new industry that was growing, air conditioning and refrigeration. When we started doing what we do today in 1952, air conditioners weren't any place. You know, maybe the movie theater had a sign out in front that said, new, air conditioned. And you go there and visit. Cars weren't air conditioned, homes weren't air conditioned. It was a very new thing. So we've grown with that industry. The countries you see here in red are places where Burr Oak Tool and Gauge today has equipment installed. More than 70 countries, more than 1,000 customers in those 70 countries. And we've been selling globally since the early 1960s. If you ask any of our employees what we're trying to do, they'll tell you we're trying to eliminate waste to improve flow to shorten lead times. And if you ask them, how are we going to do that? The first thing they'll say is we're going to work hard. We're lucky to be in a rural place where the law of the harvest is understood by people. A lot of our workforce grew up on farms. They understand that if you don't do what's necessary, you can't expect a good harvest. And they understand how that translates to the workplace. The three guys in the upper left-hand corner there, on the left is Jim Lindsley, the center is Gene. My dad is in the lower right-hand corner. Gene Eldridge and my dad are the people who took Burr Oak Tool and Gauge and our equipment to the world. They traveled just when travel was hard. I mean, when my dad went to Japan and then later to China, he went to China only a month after Henry Kissinger went to China. Not exactly a garden spot when he went visiting there. And it's upon their shoulders that we stand today. We've got great young people and our design engineers, dedicated. They're doing great work. Manufacturing is a tremendously important thing to us. On the left-hand side there, you'll see a 1965 vintage Cincinnati Millicron machine tool. In 1965, that was the state of the art for making parts for our machines. The smallest incremental move that machine could make was 1,000th of an inch. The fastest it could go with an end mill and a feed rate was 40 inches a minute, and the rapid traverse speed was 100. Now, if you flip down to the lower right-hand corner, you'll see a Mazak machining center. That machine's smallest incremental move is 4 millionths of an inch. Its maximum feed rate and its rapid traverse rate are 2,350 inches a minute. Spectacular difference. Now, one of the differences between our organization and most others in the country is we have the Mazaks, they don't. We've worked really hard to make sure that our people have the tools that are necessary to compete in a global economy. And that's something that I see that is sadly lacking for most companies in the US. I'm going to show you this picture first. This is our old technology tube bending machine. You can see the straightening rollers in the upper left. Those were used, you'd pull the tube through there, and if those were adjusted correctly, it would straighten the tube. And this machine's called a hairpin bender. And you can see the corner of a hairpin there, in the corner a hairpin, and the machine takes tubing off of rolls, straightens it, cuts it to length, bends it. That's its job. And then those tubes are used to put in stacks of fins that come off the fin line to make a coil. And this is an evaporator coil here in this picture. And this is the machine that replaces it. It's called the Triumph hairpin bender. And it's a spectacular leap over the old machines. Part of what's been very difficult for us, once you get past the design part, you still got to build it, right? If you look at the machines in this picture here, they are truly world-class. There are no machines made on the planet Earth that are better for what these machines are doing than these machines. The tragedy of this picture, in my view, is that none of these machines are made in the United States of America. There is absolutely nobody that can do what these machine tool builders have done for Burr Oak Tool. And the main reason is because they got off the playing field and they died and they went broke, they're gone. The machine in the center is a jig boring machine. It's made by a little company in Japan called Yazda. And if you would have told me 10 years ago, I'm a manufacturing guy. If you would have told me 10 years ago that I could use an end mill on a machine and that I could make holes that were rounder and in a location better than I could do it on my jig grinders, I would have told you were nuts. But technology has made this possible. This machine has nano servoing. We use a little relieved 4-flue carbide end mill, and the way we make the holes is we actually do a helical move. So this thing is servoing and delivering holes that are within a few millionths of an inch in roundness and in location. Now, the problem. Guess how many machines like this are in the United States? Oh, you guessed one. There's actually 2. But I can't put any work on that other one. There's now 3 at Burr Tool. But there's nobody I can send the work to because there's nobody that has invested in the technology necessary to make the kind of parts that I need. Most of you are old enough to remember VCRs, right? You all had VCRs. Did you ever look inside the little hatch and that little spinning head? Those were made on lathes. Do you know why there were never any VCRs made in the United States of America? Nobody had the machine tools that could make the heads. We hadn't equipped ourselves. So all the VCRs were made overseas. The accuracy, we work to extreme tolerances by most people's machine shop standards. The cutting clearances in our fin dies are 4/10,000ths of an inch. That's how close the surfaces are together. That's 1/10 the diameter of one of your hairs, 4/10,000ths of an inch. There are hundreds of these things in these progressive dies. When that die closes at a speed of 300 strokes a minute, that tooling better be exactly where it's supposed to be, or you're going to have hard tool steel crashing into hard tool steel. So the accuracies that we work to are extreme. We're bumping up against the laws of physics. Where we manufacture parts, it is 20 degrees Celsius 24/7. And it has to be that way because if it's not, the parts and the machines will change size sufficient to make it not possible for us to manufacture those parts. This is something that's been very difficult for us. When my grandfather started the business, all of our raw materials, all of our purchased components, all of our machine tools were from the United States of America. Because the companies in 1952 that supplied us, and some of the names are here for machine tool builders, were the best in the world at what they did. They were really, really good at it. And they're all gone today. And they're all gone today because they committed suicide. They committed suicide. They stopped innovating. They stopped reinvesting in their plant and equipment. They stopped training their people. It was all about the short term. It was all about, are we going to pay a dividend this quarter? I remember going to Cincinnati Millicron in 1986, young engineering student, and I visit their main plant. And at the time, they were called the General Motors of the world machine tool industry. They manufactured in 5 countries. They were great. So I'm expecting great things, and I go in this main plant, and they take me on a tour. And I'm like, are you kidding me? This is like visiting Greenfield Village, for crying out loud. There wasn't a machine tool on their floor that was less than 20 years old, and most of them were from the 30s and 40s. And I turned around to the guy leading me, and I said, this is crazy. You're going to go broke. And he just laughed at me. I was just a stupid kid. What did I know? They were Cincinnati Millicron. But the guys in the tower that were making the decisions by then knew absolutely nothing about machine tools. All they cared about was, what is our stock trading at, and are we going to pay a penny dividend this quarter? That's all they cared about. And I couldn't find anybody in that organization, from a custodian to the CEO, who thought there was a thing wrong with how they were doing business. When I visited their lathe facility, they had a 1930 planer. For those of you who don't know much about machine tools, a planer is a machine that takes a single point tool and just scrapes a chip. Really slow. So they're bragging because they've put a CNC control on a 1930 machine. And there's a guy there reading a textbook, or reading a novel, as this machine bed's getting worked on. And I said, you think this is good? And he goes, yeah, this is great. We put a CNC control on it. I said, you know, everybody else in the world is doing this with a 5-sided machining center, and what comes off of here is ready for assembly. Yeah, we know that, but we think we get a flatter waste surface this way. Death by suicide. Ignorance. Voice of the customer. I tried to be the voice of the customer at Cincinnati Millicron. I wanted a lathe that could pick off a part and do secondary operations, you know, so it's done when it comes off. And they listened to me patiently, and then they said, well, there's no market for a machine like that. And I said, well, how would you know that? Well, we went out and hired a marketing company to study our market for us to tell us what we should be building. I said, uh-huh. I said, well, who did you ask? So he starts reading off what was then a list of blue chip companies in the US who were all going broke. I said, did you ask anybody in Germany what they wanted? Well, no. Did you ask anybody in Japan what they needed? Well, no. I said, do you guys export anything? Well, no. I said, you're going to die. You're going to be toast. 2 years later, that plant was gone. Boy, they were arrogant people. One of the leap forwards that we did is in fin lines. Now, a fin line, again, is the high-speed press and line equipment necessary to make the fins for your air conditioner. This chart shows die tonnages. The green that you can see on this chart are areas where we and our competitors could manage 5 years ago. 100-ton presses are the largest ones that were generally used in the industry until very recently. And you know, and I looked at this and said, oh my gosh, you know, we've got to change because people are changing the materials they're stamping, they're changing their tempers, and they don't understand the consequences of that. So we leaped ahead, and we made what we call the FP1400, a press that was literally twice as strong as anything in the industry at the time. It was balanced so it could run at high speeds, and it was at a price point very similar to the 100-ton offerings. And it was a very easy thing then to go to a customer and say, the reason you're having trouble with the quality of your components is because you're using a 1970s vintage strategy to try to make fins in 2010. If you put your die in this press, your problems are over. And they were amazed. Their engineers had never gone through the numbers, which kind of amazed me. With high speeds, it becomes difficult to get the fins down onto what we call the stacker rods because gravity won't work anymore. And if you try to blow them down with air, that doesn't work very well either. So we started servoing what we call that suction sheet, that part you see in the middle there, to actually place the fins down over the ends of the stacker rods. So that enabled our machines to run much faster than anyone else's. Everyone had started using evaporative lubricants instead of oils, and they were having problems with their stacker rods corroding. So we changed ours to 17.4 pH stainless, and we heat treated them so they became much stiffer in bending, and they never had to worry about corrosion and fins not sliding down the rods. If you look at why we did it in terms of the customer's productivity, I mean, you look at what happens to the number of fins they can produce. This is the old 100-ton technology, and the 1400 is the same size, but by doing more in the die area of the press, you can double the output with the same floor space, which customers are thrilled by. Anticipating customer needs can be a difficult thing because a lot of customers don't understand their needs. In the case of the fin line, when we would go to customers and tell them the reason you're having troubles with the quality of your parts is because you've changed your process and you didn't understand how that impacted the operation of the machine tool. Well, on the hairpin bender side, there were people all over the world that had troubles. And this is a list of competitors we've had that have gone out of business because they didn't listen to the voice of the customer. They didn't do the things they needed to do. In the case of the Triumph bender, we just threw away the book. And we on purpose used some young engineers in the design who didn't know anything about hairpin benders. Because one of the problems you have leaping to the front sometimes is, as Henry Ford would say, an expert was somebody that he could no longer use because what experts could tell you was all the reasons why you couldn't do a thing. And he wasn't interested in why you couldn't do a thing. He needed to find out why you could do a thing. And this machine, when customers first see this machine, they're just in complete shock and awe compared to what we produced previously and what our competitors produce. This shows you what happened in terms of cycle times. In the blue bars are the old hydraulic hairpin benders. The red bars and the greens are the short and long version of the Triumph hairpin bender. And the lengths are on the left, a 1 meter, 2 meter, 3 meter, and 4 meter machine. This is what happened to the footprint of the machine. Everybody cares about floor space. When you tell them the new machine just crushes 2 of their hydraulic machines, and oh, by the way, it takes 30% less floor space than 1 of their hydraulic machines, they go crazy. When you tell them the length changeover time drops from 20 minutes to 10 seconds, they go crazy. Because setups, short runs, everywhere. When you tell them to change over tooling diameters, it dropped from 3 hours to 20 minutes, they go crazy. When you tell them it's 70% more productive, you sometimes get a phone call. One of our best customers in the United States is a company called Goodman, and Sam Bickman is the vice president of Goodman. They're owned by Daikin now. Daikin bought them about a year ago. But I got a phone call from Sam, and he said, hey, I just had my manufacturing managers in here from all of our plants, and they told me that this new Triumph hairpin bender of yours is the most significant advancement in coil-making machinery that any of them have seen in their working lifetimes. I said, well, that's great affirmation, Sam, thanks. He said, but I want to complain about something. I said, what's that? He said, we're seeing 300% productivity improvements, not 70. Why are you advertising 70? I said, well, because you aren't always going to get 300. 70 is conservative. They got 300 because they were working on aluminum, which a traditional bender can't hardly do because it has belts that feed the tubing. The aluminum oxide comes off on the belts, they get oil all over them, they slip, and just nothing but trouble. And so people are always trying to adjust the machine, trying to fix it, trying to get it back in production, and the Triumph bender just keeps running because there are no belts. We clamp and pull. The other thing that there's never anybody adjusting is the straightener, because there is no straightener. We just got rid of what was a huge problem for customers, adjusting the rollers. In any facility you go to in the world today where they use hairpin benders, there is a war continuously between shifts. The night shift says, those blankety blank guys in the day shift, they don't know how to adjust the straighteners, so we spend 20 minutes every morning, trying to get the straighteners adjusted. And the flip side of that happens at the other end of the shift. Those guys don't know what they're doing, and we have to adjust. We stretch straighten the tubing on the Triumph bender. There's no rollers. There's no tooling to buy, and it's always right. You also don't work hard in the tubing. Every time you go through a set of rollers, you're deforming the tubing, trying to change its shape to make it straight. When you stretch straighten it a 1/16 of an inch or an 1/8 of an inch, now you don't have wrinkles in the bend of the hairpin. The other thing that was a great experience to have at Goodman and several other places was I'm sitting in a meeting down there, and a guy slides an SPC graph of what's called peg leg, which is the difference in leg length on the hairpins, across to me. And he said, I thought you should see this. He said, if I hadn't collected this data myself, I would have never believed it. But at Goodman, they were struggling to get a CPK of 2.2 or 2.3 with their hydraulic machines. With their new Triumph hairpin benders, they were at 5.1. And they were just incredulous. It's a green machine. It has a fraction of the electrical consumption because the hydraulic system's mostly gone. All we do with it is clamp. There's no compressed air required unless you're going to do some manual lubrication. The hydraulic machines always had to have cooling water supplied to keep the hydraulic system cool. There's no cooling water necessary. And the maintenance is just crushed. The investment, the new Triumph bender costs 30% less than the old machine. If you put together cost of ownership on a spreadsheet, some of our competitors are Chinese companies, and you can buy a hairpin bender from them for less than half of what ours costs. But if you spreadsheet what your shop floor costs you, what the energy costs flowing into the machine, how many hairpins it makes, if they gave you the Chinese machine for free in less than a year, that would be a terrible decision. Your cost of ownership is lower with the Triumph bender. And I think that's the kind of, who can say no to that? I mean, what a spectacular win for us. So how can US-based manufacturing companies survive and thrive on a global stage? They've got to develop their people. They've got to embrace leading-edge technology. They've got to listen to the voice of the customer. And you've got to innovate. And the convergence of all those things can bring spectacular success. You know, I wish I could send out parts to be manufactured on the outside, because that would help me. Right now, we're going through a difficult transition. We're trying to quadruple the output of our Triumph benders. We're building the largest addition in our company history. But we have to do it all organically, and that's a tragedy. That was something my father wouldn't have faced. It's something my grandfather wouldn't have faced, but it's something that we face today. Thank you for your attention. Be happy to answer any questions you might have about our experiences. Yeah.
How do you handle intellectual property for the new technology that you have?
You know, for years and years and years, we had patents. But if you think about the value of a patent today, I don't think it's very high, especially since we export our technology every day. You know, we send machines overseas. A patent in China is worthless unless you're a Chinese company. There is now a little bit of traction happening in China. But we have stopped getting patents because we don't think they're of any value. And we think that what we need to do is be innovating fast enough that it doesn't matter if somebody copies what we did last year or the year before. So who cares about patents? Change is easy if you're leading it, not so easy if you're following.
Get a microphone. You were talking about this Triumph machine. What did you go through to develop it to be so much better? In terms of your internal redesign, rethinking, et cetera.
Well, let me tell you two different stories, because there was a machine, a new hairpin bender that was designed in 2000 that we called the Millennium Bender, and it was just going to set the world on fire. Here's the problem with that machine. It was all about our chief engineer at the time. He didn't care what customers said. If customers disagreed with him, what he would say is, well, they just don't understand. And my dad really liked this guy, and my dad was the president of the company at the time and was calling all the shots. And so this piece of junk got built. We spent $1.5 million developing that machine. And we sent it to one of the only customers on the planet Earth that might have cared about it, here in the United States. And they ran it for a year. And we had a continual stream of people going down, fixing it and changing things and whatnot. And after a year, they said, you know what? We'd like you to take this back. They'd been using it for free. And give us one of your standard hairpin benders. There's validation of a job well done, right? And so the second time around, what we did is we gathered people around a table, some young guys who were brand new to the organization and some old guys who had a lot of experience but were very dynamic in they didn't cling to the old ways. And one of the things that I've noticed about people is that innovation, you don't stop being innovative as you get older usually. If you're a hot rodder when you're 25 years old, you're probably a hot rodder when you're 65 years old. You know, that kind of hot rodder mentality is something that either people have or they don't have usually. And so we had some of those hot rodder mentality guys that had 30 years of experience at the table too. And they just said, what if? What if? What if? What if? And we built a prototype machine based on their what ifs, and we sent it to a customer that does nothing but makes hairpins for 3 months. And afterwards they said, we don't want to send it back. This is amazing. And we had some great feedback from there too. The Carrier Corporation is one of the customers who buys from these guys. And a Carrier engineer called them and said, I got some SBC data from you, and this can't be true. And so the guy lived out and said, I'll tell you what, when you get the hairpins, you check them and you call me back. And so the Carrier guy did that. And he called him back and he said, how in the heck did you do this? You know, this is not even possible. And he said, well, it's a new bender from oak. And so a whole different way of doing things.
Hi, My question, a couple of different questions. What % of your sales is invested in R&D every year? And two, what's your opinion of making the R&D tax credit permanent for U.S. businesses? And then my third question is, you're based in Sturgis, Michigan. What are some of the challenges you face and overcome to recruit talent to your company? Thank you.
Okay, you might have to remind me of some of that along the way. Let me start with the R&D tax credit. I would get rid of that in a heartbeat, along with the entire IRS. One of the things that I'm pretty passionate about, and this is something that I've become more and more passionate about recently, when people ask us, what is your greatest risk to the long-term viability of your organization? Without hesitation, I can say the federal government of the United States of America. Okay? And that's really true. When my grandfather died, because he wasn't, he was an entrepreneur. You know, he thought he could do whatever he wanted to do. We ended up writing a check to the federal government for $17 million. Death tax, right? He'd committed the ultimate transgression in their eyes. He had died. $17 million. Can you imagine how much better our organization would be today if we would have had that $17 million to use in a useful way? Today in Washington is an abomination that the founders would never have recognized. And unless we wake up and get that fixed, it is going to crush all of us. Sorry about that. Your other...
Percent of revenue spent on R&D every year, and then finally, unique ways you're recruiting talent to Sturgis, Michigan.
We're about 5% right now on R&D, and that'll go up. Part of our large expansion we're doing right now is we'll have our own skunk works. I mean, oh boy, am I a fan of Kelly Johnson and the amazing things those guys did at Lockheed. If you've never read Kelly's biography, get a copy of it from a used bookstore or Ben Rich's story. I mean, I'm an airplane guy, okay? Confession. The SR-71 reconnaissance airplane was certainly the most brilliant piece of engineering ever done by any group of people anywhere ever. In 22 months, they went from a clean sheet of paper to an airplane that could cruise at speeds exceeding Mach 3. The last flight of a Blackbird in 1995 was from Los Angeles to Washington, D.C., and it took 64 minutes. They flew that airplane in 1962 for the first time. There were never more than 300 people at the Skunk Works. Just amazing. So that's, boy, would I like to have our R&D group be like those guys. Oh yeah, recruiting talent. It's nice to be in a farming area where you have a lot of people who have great mechanical skills, okay? And they know how to work hard. They get it. They don't think the world owes them a living. And that's a good thing. Now, in terms of engineering talent, we have a pretty good relationship with a couple of universities. One of them is Brigham Young University. Go figure. I'm a graduate. They have a brilliant program there they call Capstone, where one of the graduation requirements is that everybody in engineering has to be involved in a new design project, solving problems in industry. And every year at Burr Oak Tool, we have a capstone team, a group of engineers and a faculty person that works for us on some kind of problem we need solved, sometimes two of them. And that allows us an opportunity to see these guys, to measure them. You know, they're working for us. And I would encourage anybody to do a thing like that, because there's nothing better than having them on your floor, and you're going to figure out really quickly if they're the kind of people you want to have live there. For some people living away from, we also try to hire married people, not single people, for obvious reasons. They're a lot more stable. Sometimes, if family's too far away, that's a problem. So we try to find people who are going to be okay living out in the middle of nowhere and okay not living next to the grandparents, and that's challenging.
Do you have any type of apprenticeship programs with local community colleges, or is it the farm talent And do you see a role for community colleges and STEM education in innovation in the United States?
I think if they got it, that might be a viable path. There are some programs in Michigan still that do a reasonable job with vocational education and with teaching skills that are relevant in the manufacturing environment. But over the last 20 years, there's been a wholesale bloodbath of programs like that at all levels in the area of the country where we live. You know, the school that Henry Ford established, for crying out loud, they shut down. And that same woman, I know she thinks she's doing a great work. She came to our local community college and shut it down, their program, their vocational. They have no machine shop anymore. They do have an auto shop, which is kind of amazing to me. But the real problem is high school guidance counselors. I've never met a high school guidance counselor that I thought was worth a tinker's damn. There may be some around, but I've never met one. And what they're telling every kid is, oh, you don't want to be involved in manufacturing. That's just, he's dirty, difficult, dangerous. These guys. You need to go to Michigan State and get a history degree so you can work at Dairy Queen. Okay? You're laughing, but it's true. 70% of the graduates of Michigan State University can't get a job in the field they were educated for. Why? Because the school is run by the government. And it does not respond to market forces whatsoever. This is true of state institutions all over. They just keep cranking out history majors or communication majors or whatever other useless major you want, whether there's a place for them or not. I'm being a little tough there, sorry. But manufacturing is just treated as the red-haired Irish stepchild. And that's got to stop, because manufacturing is one of the only things that creates wealth. And we have been eating the seed corn in this country for 50 years. We have been spending more and more of the nation's wealth and other people's wealth overseas, borrowing money to build bigger and fancier houses for smaller and smaller families. We stopped having children. We stopped teaching people about manufacturing, and we are going to rue the day. It's happening already. I mean, the standard of living for Americans is dropping. Real wages are dropping. If you go back to 1914, Henry Ford, $5 a day. Okay? Outrageous. That's what he paid his factory workers. If you convert that to gold and pull it forward to our day, because you can't use dollars because there's 100 to 1. I mean, the government has inflated the currency just crazy. $120,000, okay, annual wage. But that was also your take-home pay. There was no federal tax. There was no FICA. There was no Social Security. There was no state tax. It was all yours. Made a lot of progress, haven't we? No. Thank you.
Thank you, Newell. It occurs to me that we talk a lot about different kinds of high technology, and there's so many types. There's 3D, and there's the software simulation and the design software and things. Maybe we don't talk enough about machine tool technology and the importance of that. So thank you very much for sharing your thoughts with us. Our next speaker is Robert A. Lutz, retired Vice Chairman, General Motors Company. Really probably doesn't need much of an introduction, but on May 1, 2010, Robert Lutz